how much mathematical power you have that you can work out a constant like pi to very high precision.
So for the next 2,000 years, this is how everyone carried on, bisecting polygons to dizzying heights. As pi passed through Chinese, Indian, Persian, and Arab mathematicians, each contributed to these bounds along Archimedes' line. And in the late 16th century, Frenchman Francois Viette doubled a dozen more times than Archimedes, computing the perimeter of a polygon with 393,216 sides. Only to be outdone at the turn of the 17th century by the Dutch Ludolf van Keulen. He spent 25 years on the effort, computing to high accuracy the perimeter of a polygon with 2 to the 62 sides. That is 4 quintillion, 611 quadrillion, 686 trillion, 18 billion, 427 million, 387,904 sides. What was the reward for all of that hard work? Just 35 correct decimal places of pi. He had these digits inscribed on his tombstone. 20 years later, his record was surpassed by Christoph Grienberger, who got 38 correct decimal places. But he was the last to do it like this?
Pretty much, yeah. Because shortly thereafter, we get Sir Isaac Newton on the scene. And once Newton introduces his method, nobody is bisecting n-gons ever again.
The year was 1666, and Newton was just 23 years old. He was quarantining at home due to an outbreak of bubonic plague. Newton was playing around with simple expressions like 1 plus x all squared. You can multiply it out and get 1 plus 2x plus x squared. Or what about 1 plus x all cubed? Well, again, you can multiply out all the terms and get 1 plus 3x squared plus x cubed. And you could do the same for 1 plus x to the 4 or 1 plus x to the 5, and so on. But Newton knew there was a pattern that allowed him to skip all the tedious arithmetic and go straight to the answer. If you look at the numbers in these equations, the coefficients on x and x squared and so on, well, they're actually just the numbers in Pascal's triangle. The power that 1 plus x was raised to corresponds to the row of the triangle.
Right, and Pascal's triangle is really easy to make. It's something that's been known from ancient Greeks and Indians and Chinese, Persians. A lot of different cultures discovered this. All you do is, whenever you have a row, you just add the two neighbors, and that gives you the value of the row below it. So that's a really quick, easy thing. You can compute, the coefficients for 1 plus x to the 10 in a second instead of sitting there doing all the algebra.
The thing that fascinated me when I started looking at those old documents was how even, I don't speak those languages, I don't know those number systems, and yet it is obvious, it is clear as day that they are all writing down the same thing, which today in the Western world we call Pascal's triangle.
That's the beauty of mathematics. It transcends culture, it transcends time, it transcends humanity. It's going to be around well after we're gone.